Okay, morning guys. Good to see you again. Hope yesterday went okay. Right, today, now I just want to start by saying that I've been so impressed actually with some of the work you've been submitting on OneNote. Please do continue to submit it through here rather than emailing. It's so much easier for me to check it, and it keeps it all in one nice neat place. So if we do Anna Sharma as an example, look at that. Look at the quality of that work. Well done. And what she's doing is really, she's putting a date there, so it's really clear, and then she's submitting it really nicely, and then I'm assuming she'll put today's date and do the same again. So please do. A lot of you are now doing that. Please get into the habit of doing that rather than emailing. Remember, you do that by inserting picture for an image or print out for a PDF. Right, okay, now let's get on with the actual lesson. Okay, I'm going to disappear. So, a few of you emailed in saying you had a bit of difficulty with the surface area questions. So we're going to do a couple of questions on that. Now, so title, which is the date is the 27th. Surface area continued. I'm going to look at a few questions from the book that seem to be the ones that, let's look at question 10. Now I will say question 4, I think there's an error in the mark scheme. Error with answer there. There was an error with the answer, so just ignore question 4. I know that caused a few of you a few problems, so that's very frustrating. But question 10 we're going to start with. This is on page 243. If you were fine with these questions, you can skip the video and go through to the end bit. But I'm just going to go through it, or you might benefit from having a look at how I answer these questions anyway. So it says we've got a surface area, we've got a cone for question 10, and it says the surface area is 20 centimeters squared, okay, and the radius is 3 centimeters, and it says find the slanted height. Find the slanted height. So find the slanted height. That's the slanted height. Well, we know the formula for a cone. The surface area of a cone is, the curved surface area is pi r l. So I know it's 20 because pi, I know the radius is 3, and l is the slanted height. So I just need to rearrange that equation. So l is going to be 20 over 3 pi, which is equal to, if I do that in my calculator, 20 divided by 3 pi is 20.94 centimeters to 2 dp. Okay, so that's question 10. Question 14 was another one that was a bit tricky. So question 14 was one that, so we've got a cone and it's filled with water, okay, and it says find out the area of the cone that it's not contacted in water. So it's this, so the water is in there. The area of the cone is going to be the inside bit. So it's the inside bit around the outside. So it's sort of going to be this area there on the inside, okay. It does also say, it gives us some dimensions. The height, the vertical height is 12 centimeters. It gives us a diameter of 9 centimeters, and this, it does give us a depth of 4. The water's 4 centimeters high. Okay. Right. What you've got to spot here, and I'm going to flip it. Well, I'm going to so it's going to be the big cone. The big cone there. Which would be the surface area of the whole thing minus the water. So if I minus the surface area, the curved surface area of the water, so minus the water curved, then I should be able to get it. Okay. Now, at this point, so the curved surface area, remember, so the formula for the surface area is pi r l. L, not 12. So if I look at the big one, I need to do a little bit of side working here. If I split that in half, I know that the height is 12, I know the radius is 9, so I can get L of the curve, the slanted height, by using Pythagoras. So x squared is equal to 9 squared plus 12 squared x turns out to be, you can work this out for yourself, 15. So I know that the slanted height of the big cone is 15. Right, the small cone, well, that's 4 centimeters high. I don't even know the radius of the small cone, but I do know that it's similar triangles again. Quite often cone questions are similar triangles. And I know that from the big one to the small one, the height goes down by a magnitude of 3. So to get from one to the other, I just need to divide by 3. So I know the radius is going to be 9 divided by 3 centimeters. Okay, this is the water, this one. Right, now if I go back again and do some side working, because again I need to work out the slanted height of the small cone. The height of the small cone is 4, the radius is 3, and again use Pythagoras, x squared equals 3 squared plus 4 squared. And a lot of you will know that is a Pythagorean triple. X is 5. So the slanted height on this little cylinder is 5 centimeters. So the total surface area is the curved surface area of the big one, which is pi times 9 times 15, minus the curved surface area of the water, which is pi times 3 times 5. Okay. Now, if you do put that into your calculator, you get an answer of, let's just try that, 120 pi, which is equal to 377 centimeters squared to 3 significant figures. Okay, those two questions there, particularly question 14, is quite a tricky one. Do take some time to have a look through that again, and it would be worth writing that down as notes as an example question. Okay. Right, that's all we're not going to do anything new today, but your work today is, now you'll be pleased to know, Hegarty is back up and running. So I have set you, I'm going to clear some of your tasks, and I'm just going to set you probably the task on surface area that I did set the other day. So I'm going to set you that task. If you've already done it, I may be setting you another one as well. But your task, what you need to do today is complete the Hegarty and upload workings to your OneNote page. That's really important. Okay. Good luck, guys. Have a good weekend. Stay safe, and I'll see you again next week.